Hi, this is Mrs. Pinkerton, and today we're talking about 2.1 types of chemical bonds. Just for review, let's remember that our metals are all over here on this side of the periodic table, minus hydrogen, and our nonmetals, including hydrogen, are all over here. So we're talking about metals and nonmetals when we talk about types of chemical bonds. So the first type of bond we're going to talk about is ionic bonds. In ionic bonds, there's a transfer of electrons from your metal to your nonmetal. And this creates a positive ionic charge on the metal and a negative charge on your nonmetal. And that positive and negative charge, remember that opposites attract, so that electrostatic attraction between the two charges is what forms that bond. So, transfer of electrons between a metal and a nonmetal. Some of the properties are that ionic bonds have a high melting and boiling point. They have a crystal lattice structure that we'll talk more about in further units, and they conduct electricity in solution. So again, if we dissolve them in a solution such as water, or if we melt them to a molten state, which again would be a high melting temperature. Examples of ionic bonded atoms are sodium and chlorine, sodium chloride, sodium hydroxide, NaOH, zinc sulfate. So those are all examples of bonds between metals and nonmetals. The second type of bond is a covalent bond, and a covalent bond is between two nonmetals. So it's a sharing of an electron. You can see in the little diagram here that each of these atoms have one unpaired electron. They share those electrons to form a paired electron here. And that's what forms the bond. It's a covalent bond is formed by the sharing of electrons. And they can be what we call polar or nonpolar. So what is the difference between polar and nonpolar? I'm going to jump down here. If it's polar, there's an uneven distribution of that sharing of electrons. So that means one atom has that electron closer to it than the other. And we sometimes call it as like a pull. So if you think of like a tug of war, and one side is pulling that bandana on the rope closer to them. And nonpolar is an even distribution of the electron. So again, if that tug of war, that's if you're exactly tied. So that electron is not closer to one atom or the other, and we call that a no-pull. So what are the properties of covalent bonds? They have low melting and boiling points, and they are poor conductors of electricity. So you'll notice the opposite of an ionic bond. And examples of covalent bonds, remember they're all nonmetals, so we're only on this side of the periodic table plus hydrogen, the pink side, water, carbon dioxide, methane, any atoms together that are all nonmetals. The last type of bond I want to talk about is metallic bonds, and these, as in the name, are bonds between metals. So electrons are not associated with a single atom, but are what we call delocalized. Meaning, as we can see in this image over here, that the electrons can move throughout. So we've got all these positively charged metals or cations, and we call this a sea of electrons. So the electrons are free to move through the material. They have high ductility meaning it can be made into wire, pulled into wire. And malleability, meaning you can pound it or shape it, and you move that metal shape around. They have a high melting and boiling point, and they're high thermal and electric conductors, meaning, and we know this with metals, that heat can move through that easily as well as electricity. And these are copper, aluminum, gold, silver, are all examples of metals. And it can be more than one metal in a metallic bond, but we're dealing with pure metals when I'm giving you these examples. Let's go back to our covalent bonding. And remember, with covalent bondings, they're sharing electrons. And we talked about this polar and nonpolar effect. We call these dipoles as well. So what's a dipole or a dipole moment? A dipole moment is a measurement of two separate electrical charges due to a difference in electronegativity. And recall when we were into periodic trends, we talked about trends in electronegativity for atoms. Atoms with high electronegativity will develop a negative partial charge, and we signify this with a little delta and a minus, meaning it's got a negative dipole. And atoms with low electronegativity will develop a positive partial charge. And again, this is only between covalent bonds when electrons are shared. So an example over here is hydrogen and chlorine. And hydrogen, as we can see here on our periodic table, has an electronegativity of 2.1, and chlorine has 3.0. So chlorine has very high electronegativity, hydrogen is lower. So that means this chlorine is going to attract the electron closer to it. So the electron would be closer here, creating this partial negative charge or this negative dipole. Because the electron is being pulled closer to the chlorine, this hydrogen is going to have a partial positive charge. We also signify this with an arrow. The tip of the arrow is our negative dipole, and then we make a little plus on the other side for our positive dipole. Here's examples of how this is illustrated with water. Notice the arrows go towards oxygen, which is more electronegative, and away from hydrogen, and then they put these little delta positives and delta negative on the charges. And there's a couple more examples here for you to see. This boron trifluoride is a good example because here fluorine is more electronegative. So actually the electrons are being pulled away from that central atom, and the central atom is more positive. So in AP, all bonds are considered to be polar, to have these dipole moments, except carbon and hydrogen, and something that's bonded to itself, for example, maybe two oxygens, right? So oxygen bonded to itself would be nonpolar because it has the exact same electronegativity. So here's an example. It says place the following bonds in order of increasing polarity. So we're going to put the lowest polarity down here. We're going to put the highest polarity over here. We have carbon bonded to hydrogen, carbon and fluorine, carbon and carbon, carbon and oxygen, and calcium and carbon. First thing I notice here is calcium and carbon. Calcium is a metal and carbon is a nonmetal. So this is actually going to be an ionic bond. So it doesn't experience polarity, but for this example, we're just going to put it way over here as highest because it's actually going to transfer its electron and have create ions. Now, the lowest polarity would be something bonded to itself because it would be equal. So if I see here carbon to carbon, carbon bonded to itself, it's completely nonpolar. So it's going to pull on those electrons equally. They both have an electronegativity of 2.5. The next one, I have carbon and hydrogen, carbon and fluorine, and carbon and oxygen. So those are the ones I really need to consider. So let me highlight those. So I have carbon I have oxygen, I have fluorine, and then I have hydrogen. So the ones with the greatest difference in electronegativity will have the greatest polarity. So carbon and hydrogen have 2.5 and 2.1. That's a 0.4 difference. Carbon and oxygen have a 2.5 and 3.5. That's a 1 point difference. And then carbon and fluorine has a 2.5 and 4.0. So that's a 1.5 difference. So the lowest difference was carbon and hydrogen. So that would be lower polarity. Then after that, carbon and oxygen with the difference of 1. And then increasing or greater than that is carbon and fluorine with a difference of 1.5. So that would be your ranking. So now it's your turn. Pause the video and classify the substance below as nonpolar covalent, polar covalent, ionic, or metallic. Okay, so hydrogen and hydrogen, those are two nonmetals, and they're the exact same atom, so they're going to have no pole. That's a nonpolar covalent. Sodium and fluorine, we've got a metal and a nonmetal. That's an ionic bond. Zinc and chlorine, again, a metal and a nonmetal, another ionic bond. Nitrogen and oxygen, two nonmetals. They're not the same atom, so this is going to be polar. They're going to have an unequal pole covalent. Copper and zinc, two metals. That's a metallic bond. Boron and chlorine, a nonmetal and a nonmetal, polar covalent. CH4. CH4, remember CH are considered nonpolar up here in our exception. It also has something to do with the atomic structure, and same with BCl3. Based on this assignment, we would say polar covalent, but if there's equal pole on all sides, it is actually a nonpolar covalent molecule, and we'll talk about that more later when we talk about Vesper bonds. But for this assignment and example, we'll just go ahead and just look at the atoms compared to the central atom. So we're going to say nonpolar covalent. And again, BF3, let's just call, just a little asterisk here. We're going to say it's nonpolar according to the separ that we're going to learn later, or molecular structure. But again, for this example, we haven't gotten there yet. And aluminum is metallic bonding.